everyone, we're going to find the maximum and minimum values for f of x equals sine of x plus cosine of x cubed minus 12 sine of x cosine of x. This is going to be hard to do, so a technique is to write this in terms of t and make it more algebraic versus trigonomic. And I can do that by letting sine of x plus cosine of x equals t. Now to do this, you have to recall from your trig days or your pre-cal days how to solve a trigonomic equation that's linear in sine and cosine. I'm going to go over it very quickly, but it would be good to know that because you need this in calculus. So this is a 1 in front here and a 1 in front here. So the technique to solve for this would be, this is called A and this is called B. So you take the square root of your A and B, and that gives you square root of 2. And then what you do is you divide each term by square root of 2. All right. Then if you write it like that, that means there exists some angle, say theta, such that sine of theta equals 1 divided by square root of 2, while at the same time cosine of theta equals 1 divided by square root of 2. And that angle would be pi divided by 4. And then you use your sum formula, and since we can write it like that, we're going to have this. So basically we're going to have, I'm just going to simplify it, sine of theta plus pi divided by 4 equals t divided by square root of 2. And when you cross multiply, we'll bring this square root of 2 up there. All right, so that's just a quick review on that. And I don't want to, if you want to check it out, you could go ahead and expand it and see when we say that this equals, so t is, I can just rewrite this as square root of 2. I just cross multiplied sine, and instead of theta, I'm going to use x plus pi divided by 4. All right, so now that you have that, let's look for our restrictions. For this piece here, we know that this has to be in between -1 and 1. All right, but we have the square root of 2 here. So let's multiply everything through by square root of 2. So that's going to give me -2 is square root of 2 is less than or equal to square root of 2. Sine of x plus pi divided by 4, which is less than or equal to square root of 2. And that means our t is going to be, because this is equals t, our t is going to be in between negative square root of 2 and square root of 2. And that's where our restrictions are going to be when we find the minimum and maximum. And now, the only other thing we have to do is look at this sine of x, cosine of x, because we want to also write this in terms of t. So we already have a t here. We know that t equals sine of x plus cosine of x. And if you square both sides, so I'm going to square both sides, t squared and that, this will give you t squared equals sine squared x plus 2 sine x cosine x plus cosine squared of x. Using your Pythagorean identity here, that means t squared equals 1 plus 2 sine of x cosine of x. Now, what we want to do is solve. So I can rewrite this as sine of x. I want to solve for sine of x, cosine of x. So I'm going to subtract the 1. I'm going to squeeze it in here. So we're going to have t squared minus 1. Then I'm going to divide by 2. And that's going to give you your sine of x, cosine of x. All right. So now that we have everything in terms of t, let's get started on rewriting this. So now I'm going to rewrite my f of x as y equals, this was your t, so you're going to write t cubed minus 12. And now we had our sine x, cosine of x. That is going to be t squared minus 1 divided by 2. All right, now we can continue on and simplify this. 2 goes into 12 6 times. So this is going to give you t cubed minus 6t squared plus 6. Because you have 2 negatives there. All right, now let's differentiate. So y prime. That's going to give me 3t squared minus 12t. Or we can write this as 3t times t minus 4. All right, from here, when y prime is 0, we have t equals 0 or t equals 4. However, since our restrictions for our t is in between negative square root of 2 and positive square root of 2, we're only going to use t equals 0. 4 is too big. So now we have that part, and now we can evaluate all this to find the min and max. So we're going to use t equals 0, t equals negative square root of 2, and t equals square root of 2. All right, so we're going to do y. We're looking at y now at t equals 0. So if you substitute 0 into your y, let me write the y down again. Our y is t cubed minus 6t squared plus 6. So if you substitute in 0, let me write this a little better, but make it little, where t equals 0, you're going to get 6. All right, let's do where our y, and let's do t equals negative square root of 2. That's going to give you negative 2 square root of 2, that's for this piece, minus 12 plus 6. This is going to give you negative 2 square root of 2 minus 6. And the last one is where t equals square root of 2. This is going to give you 2 square root of 2 plus, no, minus 12. Still minus 12 plus 6. This gives you 2 square root of 2 plus 6. All right. Now looking at your largest number and your smallest number. Your largest number is this going to be, these are both minus 6 right here. This is your largest number, so this is where your maximum value is. So your maximum value is 6. I'll just write 6 at t equals 0. And your minimum value is your smallest number, which is this one. So we're going to write minimum value equals this. I'm just going to do an arrow there. And that's at t equals negative square root of 2. Thank you. Have a nice day. Bye-bye.